the International Titanium Association abides by these antitrust guidelines, which are also located on our ITA website for any future review. We also abide by a separate resolution which specifies that issues on price, capacity, and market forecasts from the past, present, or future will not be discussed during any ITA gathering. So ask that you just please be respectful and mindful of that. Any questions regarding suitable items for discussion should be reviewed with the ITA legal counsel prior to open discussion. And that is pretty standard for all of our conferences and meetings and going forth. And again, you can also review this at any time on our ITA website. And so with that, I would just like to start our meeting off with giving you just a brief introduction to the Industrial Applications Committee with this video. And I'm going to put this full screen so you see it better.
The mission of the Industrial Applications Committee is simply an extension of the ITA's greater mission to introduce people interested in titanium to our industry and disseminate information about titanium. Currently, the IAC, as I call it, is composed of integrated manufacturers, fabricators, distributors, and tubing manufacturers. We would greatly appreciate and are seeking participation from the end user community as well as the engineering community for process equipment. The committee offers a chance for participants to network within the titanium industry and meet other end users. Our work organizing technical presentations has moved outside the traditional ITA events. We are now working actively with NACE in the Reactive Metals Forum and with, in collaboration with KCI Publishing on the Managing Aging Plants Conference. We have found that taking our message outside the general ITA events gives us an audience of interested participants that are potential customers and ITA members. And this provides an excellent value package for the ITA and our committee members.
The SMB Pressure and Vessel Code is a standard by the American Society for Mechanical Engineers. And they actually regulate the design and construction of pressure vessels and boilers for internationally. Everything our committee normally includes metals producers, users, end users, design companies, national laboratories, fabricators, and consultants. We would really appreciate any experience with titanium on these committees. Eventually, I'll be retiring from these committees and would like to turn this over to some of the newer members, if we could. So some of the involvement will be getting involved in material specifications or materials, and also the design properties of titanium.
The ITA staff is tireless in their support of us, from managing the symposium registrations to organizing to marketing. The ITA board of directors and the staff have given us complete support.
Okay, great. And so with that, I would like to hand over the meeting to our moderator, Wendy McGowan, who is a Senior Manager of Business Development for Neotis. And we just welcome you and thank you for hosting today's meeting, Wendy. So
here I am. So good hello, everyone. Welcome. I'll say good morning, good afternoon, or good evening, whatever the case may be. On behalf of the ITA IAC committee, I'd like to thank you for joining us today. Hopefully you've, we had a lot of really great papers and presentations, and I hope that you've had a chance to view several, if not all of them. And we have all but one speaker here today. So hopefully you have some questions and we can have some lively discussion. But the first thing we're going to do before we start the questions is I think everyone should be seeing the polling results. So this is the first question. when you first came in. And about every 10 minutes or so, we'll take a little commercial break and ask you another question. But you can see the results. This is the distribution of who's with us today. So it looks like we have mostly producers, a few distributors, and fabricators, and a lot of others. So again, thank you for joining us. And as Ann said, if you have a question, you can raise your hand or type it in the chat box. And I would also advise you to, it may be obvious, but tell us who you're addressing your question to, so we know who the question goes to. So let's see, we'll get off with John Banker. Are you with us?
Yes, I am.
Okay. So the first question we have is, what are the major differences between explosive clad operations, and how can an end user determine which company to work with?
The major differences relate to the technical experience, technical knowledge, and to some extent the company culture and the quality culture. The user, the buyer, it's important to really know and understand the capabilities of the producer that you're choosing to work with, or you're wanting to work with, to better understand exactly their experience with titanium clad, because titanium clad is a relatively broadly used product with, you know, tens of millions of pounds over the history, but it's a very niche product, and your producer needs to know the technology. You need to vet him. Does that help answer the question?
I think so. Thank you.
Thank you.
All right, let's move on to Bill McDonald. We have a question regarding your ASME code case. In your work on this code case, do you find the titanium industry well represented within ASME boiler pressure vessel committees?
Hey, thanks, Wendy. Hi, everyone. So before I answer, I just should say I'm new to the ASME committee in the last 2 years, and I'm on the subgroup non-ferrous alloys. So my mentor has been, to a certain extent, is Rick Sutherland, who I think has been carrying the ball there, as you saw in the opening segment. And I feel like, yeah, we are well represented at the initial level where titanium activity is taking place at the subgroup, and then also at the main group for materials. So since I've been there the last 2 or 3 years, I've seen a number of records and ballots going through to clean up some of the titanium activity. There's been work on, for example, redoing the grade 12 stress allowables in table 5, for example. And Rick has been very active in the last year or so, incorporating standards for plate, sheet, bar, and forgings into the code. So there's a little bit more activity, and certainly I've seen visitors show up from, I think, a couple of the manufacturing companies. I'm pretty sure a gentleman from TIFAB, was showing up, or Tricor, and we're interacting with them, trying to get at least some feedback from the industry as to what is important to them. So I feel that now that I'm involved, and my involvement was really started because I also work for Special Metals. So my role in subgroup non-ferrous is funded really by my company to push along nickel alloys. So I have kind of a unique role, whereas I really like titanium a lot better than nickel, but my boss is a nickel guy, so I have to keep him happy.
Okay,
Answer that question.
all righty. Thank you. Let's see, let me just check here, make sure I haven't missed anyone. Doesn't look like it. Okay. Tim Mornian, you with us today? You'll have to unmute yourself, Tim.
It's because I had nothing to say.
I'm sure you do. So I have a question for you. So the presentation you gave on the IMO 2020 rule, now that we're 10 months into this rule, what do we know?
Well, the law of unintended consequences reigns supreme. Things were going great guns relative to the marine industry installing scrubbers. And for just a short update, that's so that they can knock down the sulfur airborne emissions. And this was accomplished by bringing out some low sulfur fuels. With the downturn due to the reduction in petroleum consumption as well as COVID, they kind of go hand in glove, obviously. Shipping companies have stopped installing scrubbers almost completely because one of the reasons being the lower price fuel is so attractive, it's now viable to just stick with the old and not let the regulation get in the way of making a profit. So to be more specific, a year ago in January, the pricing for the alternative fuels was coming down, and it was an economic decision to make the transition to the better fuel or to install a scrubber. Now with the petroleum pricing being depressed like it is, it makes more sense just to continue to burn the old fuel and revisit things when the economy gets back on the rails. So this COVID has really turned over all of the market drivers that were in place as of December 31st, 2019. And everything is pretty much in a wait and see mode. So if you're in the scrubber fabricating business, you're probably off seeing the grandkids.
Okay. I kind of have a follow-on question, but maybe you've already, oh, well, let's see. Let's take a break here. You should have your question number 2 popped up. If everybody could go ahead and we'll take a little commercial break here and tell us what your job function is. And then Ann will post those results in just a few minutes. And I'll go ahead and ask a follow-on question, Tim, while we're waiting for
Sure.
the results to come up. So what do you believe would be the key to advancing this concept to actual use of titanium on shipboard exhaust scrubbers?
Well, good question. Getting past the preconceived notions about the price of titanium, the difficulty in working with it, and whether or not it really brings a solution to the unpleasant reality that stainless steels are not surviving in scrubber service. So I would say a public relations campaign to educate the ship owners that an alternative exists and that looking at the total cost of ownership, it's actually cheaper. So a lot of preconceived notions are in the way as opposed to technical challenges.
Okay, all right, good. Let's, Ann, do you have the results from our survey?
Sure, they're still coming in, but we can go ahead and show those. And just for to note, anyone who is not seeing the poll, because perhaps they are viewing this on their web browser, if they are not viewing it on the app, I am putting the questions in the chat box, and you can always feel free just to answer straight to that chat box. And then we will be able to save that file and see your response. So that's always an option as well. So every time we launch this poll, just look to the chat box if you're not able to actually access this poll. So here are your results.
Okay, well, it looks like we have a good, good broad scope of people. It's not all salespeople talking to each other. So, all right. Okay, well, let's move on. Steve Sparkowicz, I know you're with us.
Hello.
Hello. Here's a question for you. Given the current price of palladium, are there alternative enhanced corrosion resistant titanium grades that can be considered for explosive bonding?
Yeah, great question. It really depends on the situation. Obviously, Ti grade 7 and the palladium grades are used for specific circumstances. Like Ti grade 12 may not have the pitting resistance, under deposit corrosion resistance needed. I think you're probably talking about hot chloride environments, hydrochloric acid and so forth. I would consider alternatives. It depends if you need ASME code or not. Cladding doesn't necessarily have to be ASME code. It doesn't have to be part of the pressure containing window, although there's circumstances where some of the welds might need those requirements. But if it's not ASME code, it opens you up to non-code materials like, well, this 475 I heard about yesterday from TIMET was pretty interesting. That's better than, not quite as good as the Ti grade 7, maybe, but maybe good enough, right? Another maybe underutilized material is Ti grade 36, which is the Ti 45 niobium. In side-by-side tests with the palladium grades, it exceeds the corrosion resistance of Ti grade 7 and allows you to go hotter, but it's not as available. So the quantity you need really may drive the decision. And a mill is certainly willing to melt an ingot to a specific ASTM grade if you want a ingot mill run quantity. If you can't, your project only needs a little bit, then that's tougher to get a small piece. Some general guidance, when you're dealing with the specialty, more expensive grades, is to, early in project life, qualify all alternatives so that when you come to the time of fabrication of clad equipment, you're not limited to one grade only. There should always be an alternative, maybe something that has a little better corrosion resistance than the grade you want. It'll allow you to take advantage of both cost and maybe lead time situations where distributor may have some material in stock. Clad projects don't necessarily require the full ingot quantity unless it's a mega project. So that can be a little tougher. And then I will mention zirconium. Some of the mill products right now are less expensive than the Ti grade 7. I've seen that in the past when the titanium prices, they quadrupled back in, I can't remember, 2008 timeframe. So depending on the situation, Ti and Zirc are not interchangeable. Zirc's not always better than Ti. But I will mention in my presentation the section on the zirconium oxide thickening would allow zirconium to perform very well in these hot hydrochloric environments. My presentation was too long, so I think the recording will be on the ITA website for the zirconium section. So hopefully that answers some of the question.
Okay.
Wendy,
Yes?
it's Chuck Young. Steve, I have a question. What about Ti 16?
Yeah, well, certainly that has less than half palladium, so that's going to help. And, I'm going to just guess that 80% of the Ti grade 7 applications could use Ti grade 16 as an alternative. The half palladium is good enough. But, without running a corrosion coupon test, either in service or, at the pilot stage, you won't know for sure. But great question.
I think
And
Phil McDonald had a question.
yep,
Yeah, thanks, Steve, for mentioning Thai 475. That could be interesting. I wish I had Jim Grauman's connected to him when you're discussing that, because he also said the half palladium grade 16 could probably meet most of the requirements. And of course, we know that palladium is through the roof right now. And the other alloy that Jim developed that we went on and off with was the Thai carbon, which he showed like a 2% carbon was equivalent to Thai grade 7 with a much lower cost alloying element. But it proved to be a little bit difficult to work with. So in the back of our minds, we're always thinking that a solution for the palladium problem could be a Thai carbon solution if there is enough interest in the industry for TIMET to get that going again.
Hey, Bill, you
What I
also
recall-
have the Thai ruthenium alloys that no one wants to make.
Yeah.
The
That's
Thai
a-
ruthenium, I know that, what's that, grade 26? I've never come across it. I don't think
Yeah.
that we have a way of direct additions of ruthenium, certainly that I've heard of. So you're stuck with a grade 28 or something like that.
Yeah, there's a variety of challenges with the Thai grade, with the ruthenium grades. They have been tried on projects, but anyway, that's a whole different subject. Not very available, but I'm sure a mill would melt an ingot if they have experience with it. I will mention the Thai grade 16, Chuck, the low oxygen grade, Thai grade 17, is the cladding grade. So Thai grade 16 has higher oxygen. You might need to use an interlayer, which would drive costs up because it's higher strength, more difficult to clad, but you get a direct clad to carbon steel with the Thai grade 17 low oxygen version. And that would be analogous to Thai grade 11, low oxygen Thai grade 7, right? That's the cladding grade, I'll say, of grade 7 is grade 11. Good enough.
all right. Thank you, Steve. I'm going to keep you on the hot seat for now, but I'll ask Ann to put up our next survey question in the meantime. How did you learn about today's event? All right, and while we're waiting for those results, Steve, so how do you measure debond areas in clad vessels after fabrication? What do you think is an acceptable level of debond in a clad vessel?
Yeah, debond, or I will call it disbond. I think John Banker gave a fabulous presentation yesterday covering the global standard, ASTM B898, and then the -20, 2020 version, covers that in detail. You're looking at a class A, B, or C ultrasonic testing criteria to scan the plates. Automated scanning of 100% of the plates are preferred. And then the class A is the most stringent criteria. You're looking for a 25 millimeter maximum size indication, approximately 1 inch. So, you know, a cladder who has good process control should pass that test on 100% of the plate with very, very rare exceptions. So really it is the standard, the automated ultrasonic testing for inspecting plates for disbond. And why do you want that? You know, plate rolling, head forming, welding operations where there's heat that may affect the interface, all can lead to a disbond on a plate that's not well bonded. It will cause, you know, an area of disbond to grow. So it's a very important inspection to inspect every plate, make sure it's good before it ships to the fabricator, and then they can go forward with confidence in plate rolling and these other operations to make the finished equipment.
Wendy, it's Chuck Young again. I got a question, maybe Steve and John can answer. If you have a vessel that is a clad vessel and you want to take a look and see if you have a disbond area where you're maybe going to cut out a new nozzle or something, what's the best way to do that?
Well, I'm going to defer to John. He's been around this for nearly 50 years, and I've got a decade or so.
Oh, thank you. Can you all hear me?
Yes.
Okay, thank you. You're absolutely right. The beginning of this question, when you're fabricating, in the beginning, you want to assure that your clad plate is free of any areas of lack of bond. And my opinion is, if I was buying a piece of equipment, I would specify UT Class A, period. That gives you some room. Now, after you do the rolling of the shells, the forming of the heads, before beginning to do any titanium joint welding, I would again do ultrasonic inspection to assure that nothing has come loose, nothing has disbonded. It is very, very rare for a disbond to happen in fabrication from one of the reliable cladders around the world. It's very rare. With the additions that we made into B898, I think it will become less rare. But if there is a disbond, then the question becomes, what do I do about it? If it's in an area at an edge where you've got to make a weld on it, you don't want to go welding on a non-bond area. Now, as Chuck had mentioned, if there's any way to move things around and get that debond in a nozzle area or an area where there's no welding, that's a good thing to do. When forced into it, shifting, if you've got a debond, shifting to where you're not welding on it is a good thing to do. But again, I think the importance is you don't want to go into production with a new vessel with a newly created disbond, and I would certainly limit any area of non-bonding to the Class B level, which is a 3-inch maximum defect. And if you can't do that, it's time to work with the fabricator, the clad supplier, to make a replacement part. And it can be a patch, it can be a replacement patch, but you need to deal with it at the time of fabrication, not let the fabricator sweep it under the carpet. And you find about it later, you find that he buried something. When you're dealing with a fabricator of limited experience with you, you really need to have a close, regular in-process inspection. I hope that helps a little.
Yeah, one last comment on that. If depending on where it would be on the plate, the disbond, you could cut that area off and weld an extension to the plate, another smaller titanium clad plate. Weld the carbon steel side and do a small batten strip type weld.
But I mean, if you had a vessel that was already in service or about to be put in service, and then they decided they wanted to put a new nozzle in, so you have to cut something out, how would you make sure? You'd have to do ultrasonic testing of that area?
Yes.
Okay, thank you.
And we had a kind of a lead-in question, follow-up question on that as well on the chat. Is there a separate specification for weld repair of disbonded exclusion clad repair, and to what extent can you weld repair?
There is, pardon me, Steve, let me take this one.
Oh, please.
There is no specification for dealing with a repair. It depends. The work needs to be managed by an experienced fabricator. And there are a significant number around the world, but they need to be folks who have proven experience to be able to deal with problems when they occur. As Steve mentioned, cutting off the end of a plate and replacing it is a solution. Now, again, when you're dealing with a well-vetted clad producer and a well-vetted fabricator, the occurrence of a condition like this is, in my experience, very unusual. I can't comment about work that is in one of our more populous Eastern countries, but if we look at the other parts of the world, I've seen one significant disbond in the last 20 years. I hope that helps.
Yeah, I have seen some remedies that involve a bolt, through wall bolt in a pressure vessel to secure the poorly bonded clad, even in the initial fabrication stage. Granted, you don't see that outside of the regions of the world that John mentioned, but typically, but I have seen that on occasion. So that's not a great repair from a reliability standpoint. The owner companies don't want through-wall bolts on high pressure vessels with strong acids in there. So anyway, not recommending that one, but I have seen it.
Bolts are better than growing disbonds.
Yep.
Depends on whether the clad is in compression or tension. It depends on the conditions of what you're looking at, and it's one that you really can't give a patent answer for other than you don't want it.
All right, thank you guys. We'll take another short commercial break. We have our polling results from our last question. I think most everyone heard about us through the ITA event. And I'll go ahead and ask Ann, while we're doing this, to go ahead and put up the next question. You can go ahead and answer that one. I'm going to close that. Okay, it looks like we have, I guess John and Steve, you're not off the hook yet. We have another question on chat. Any new solid state welding technologies like friction stir welding being investigated for repair of non-bond tie clad plate?
Not to my knowledge at the present time. There's work that has been done there. It is well documented in the history of a few of the clad producers and fabricators. We'd be glad to discuss it in detail with you at any time. But at the present time, I'm not aware of anything new. Are you, Steve?
Yeah, well, certainly it is being investigated and evaluated, and maybe not in the public domain, but those methods, some of them may be viable, but it will take a development effort, certainly funding, to bring it into common practice. But yeah, I think the world could be growing toward that eventually, maybe not in 2020. But yeah, friction and ultrasonic and other solid state methods should be looked at.
All righty. Okay, let's move to, we'll put somebody else on the hot seat now. Chris Wilson, have a few questions for you. Chris's presentation was on the work he did with the NACE MR0175, making some changes to grade 12. So the first question, Chris, is do you believe the effort that you and the IAC have put into the revision of the NACE MRO 175 requirements for grade 12 have resulted in increased awareness and application for grade 12?
Hi, Wendy. Thank you. It's a good question. Yeah, I guess short answer is yes, I do believe that it has helped. One of the things through this whole process was the fact that, you know, we got to present the data in front of a room full of people that are, you know, the decision makers for purchasing materials for projects. You know, we presented this multiple times to the MRO 175 committee, the ISO 15156 committee, multiple opportunities for folks to ask questions, you know, make sure they understood what we were trying to do and what we were trying to accomplish. So I guess in the end, you know, we put this data, we were able to show the corrosion data, the performance of the material, which, by the way, you know, passed all of the testing with flying colors. So there was no issues. And we put all of that data in front of the right people. So, you know, has that resulted in increased, you know, consumption of grade 12? I think that's to be determined. But from my perspective, you know, I think it was a great project. It has taken way too long for it to be implemented, but that's just the nature of this this standard. It's not a very easy standard to get anything added to, as anyone will tell you. It's a multiple year project. But I guess going back to the original question, yeah, I do believe that you know, this will help grade 12 consumption going forward for the industry.
Okay. I'll ask you another question, Chris. Someone was surprised to see that titanium grade 2H had a higher normalized cost than grade 12 titanium. Is this due to the increased strength of grade 12, or is the cost per pound lower versus grade 2H?
Yeah, you know, when we put this project together and we got the ballot, you know, finally approved, one of the things that came up was, well, we should really go out and, you know, kind of market this, you know, tell everyone what the benefits of grade 12 are. So in the process of doing that, I was able to steal one of Tri-Core's charts where they normalize, you know, cost of various grades, various alloys, just to do it as a comparison. You know, grade 12 is, you know, well, I'm not going to get into pricing, but we normalized the pricing and then also took into account the density and ASME design allowables. And when we did that, it was actually very surprising to see that when you consider those factors, the grade 12 was lower on the curve than the grade 2 that, you know, is the standard in the industry. So, you know, it makes you sit back and think about, you know, what are we doing here? Should we really be going after grade 12 for maybe more things, you know, not even considering the corrosion aspect of it, but it does have, you know, higher mechanical properties, higher design allowables. When you take that into account, and, you know, you could potentially reduce your wall thickness on a pressure vessel, then it makes a lot of sense. And at least for me, yeah, I was kind of surprised to see that. I wasn't expecting that, and I think a lot of people in the industry were also surprised.
Bill McDonald, you had your hand raised. I don't know if it was in response to that.
Well, I just comment on Chris's challenges with the NACE MRO 175 and ISO committees. NACE has all restructured that, and now they've got standards committees that are responsible for documents, and they just started their meetings this past week. And so SC08 is the new standards committee that's going to supervise and ballot on MRO 175. I just joined it. You don't even have to be a NACE member to join it. And on joining, you become a voting member until they start screening out too many participants from one industry or from one company. So I'm just saying, I'm on that committee now, and I can possibly help with titanium going forward should these issues come up, because I'll have a vote.
Hey, Bill, what's the name of that committee?
SCO8 Metallic Materials.
Metallic Materials. Okay,
Yeah.
thank you.
Arjan Koplico from BP is the chairman. And I think they're trying to also work with the other interesting area we're interested in is upstream oil and gas, which is SC14, which will have some materials components too.
Bill, this is Chris. One of the difficulties, I think, is you have the MRO 175 side, but you also have the ISO 15156 side. And that ISO organization, the voting members are countries, so multiple countries that are voting. So it becomes real.
Bring it up.
Yeah. It becomes real difficult when anyone wants to make a change. There's always someone out there that's going to, vote negatively, or it's just a really complicated and really long process. And I guess that's what my comment was on it, and that's why it's taking so long. The other thing to consider is that the timing on this was that they're revising the standard right now to the 2020 version. So we kind of got in at a bad time with our ballot. So we have to wait for that to pass, and which it has, the ballot on that has all been approved. That should be out before the end of the year. And then our change will be on the first technical circular going forward, hopefully next year sometime, early in the year next year. So,
there's also a rewrite committee that's rewriting the entire standard and moving everything around into 3 different requirements. Instead of having different material sections, they're going to have application, material requirements, and testing. So it's a big project that is going to confound further development, I think. Yeah. But my other comment, if we have a second, is that on the nickel side, there's been a huge issue in the last few years with hydrogen embrittlement, which titanium was kind of put into a corner because of that statement about you've got to worry about hydrogen. And for some reason, the pH nickel grades had avoided that. But now they're not. And so everybody's asking for hydrogen embrittlement testing, which could be an opportunity for the ITA or titanium industry to develop some of that data and go to NACE with that to say, we're equivalent or no better or worse than the nickel grades that we might be competing against.
All right, good. Thanks everyone for that. So we'll change subjects a little bit here, and we'll look at. I don't know if you're seeing the last polling results. Looks like most everyone picked ASTM, ASME, and I think, Jennifer, we have one more question to pull. If you want to go ahead and put that up now, and that one is in relationship to what technical conferences do you participate in? I'm not seeing that yet. You're on mute, Jennifer.
I'll have it up in just a few moments here.
Okay, all right. Well, then we'll move on. Chuck, it's your turn to be on the hot seat here.
I don't know how to talk, Wendy.
You don't. I'm not going to accept that.
Go ahead.
Okay. So Chuck spoke on the white paper that he's working on in collaboration with NACE. So on this, what common misconceptions about titanium have you had to address?
I think Tim mentioned a couple of them already, but key ones are availability, price, and the lack of I don't want to say fabricators, but the lack of welders or understanding of how to weld in a shipyard. Availability, everybody remembers when titanium, I think I called it a number of years ago, or someone did, unobtainium, when you couldn't really get titanium. And the nickel people who who have a majority of this market, really push these. And then in this market especially, they're also looking at or bringing up the fact that titanium will not handle fluorides. And that's just, that isn't a misconception, that's a truth. But in this application, there are no fluorides. So they're just throwing out everything as titanium can't be used. And just to continue on a little bit and answer maybe your next question, I don't know, but in this industry, the nickel people are going the same way they did back in the flue gas desulfurization industry back in the 80s and early 90s, where they're going and saying you can use low moly, low nickel stainless steels, and maybe going up to duplex stainless steels in areas where they know they're going to fail. And they've seen some failures instead of looking at going up to where titanium can compete on a cost basis. So we have a lot of work to do in terms of getting over those misconceptions. The survey that this NACE committee did got six surveys returned, and of those, I think 2 or 3 of them said that the lack of knowledge of titanium was the key factor in them deciding not to even look at it. So we have to educate the end users, and that would be the shipbuilders, the shipyards, and the scrubber manufacturing and design firms. Hopefully that answers your question.
I think so. The last question, I think you've already answered it. Do you believe that titanium has a place in this industry?
Yes and no. I think there are alloys that could be cheaper than titanium. The key here is going to be trying to convince the shipbuilders, the ship owners, that longer lives, the long life of titanium would make more sense than a nickel alloy. Some shipbuilders have said that they have gotten 10 years service out of some of the nickel alloys. I tend to wonder about that, and I'm trying to get the NACE committee to actually go out and get more detailed information. Right now, all they have is anecdotal information where a person checks off a box on a questionnaire. So titanium should be in this industry. It's seawater. It has high chlorides. It has some acidity, and its temperatures are reasonable. They're not up 500-600 degrees. So. And it's been proven in the FGD market when Ron Schutz of TimeEd RMI and I did our work back in the 80s, and some other people followed on that in the 90s. Titanium was shown to be the best alloy there. And these are I don't know if I think in my talk I mentioned that if one of these fails, and there was a failure over, I believe, in the Far East, if one of these fails, if a weld fails or they get a corrosion failure or a joint in a piping fails, they get what is a big waterfall into their engine room. And it can destroy a lot of their electrical. It can destroy a lot of the engine room if you have a lot of seawater coming in there.
Yeah, it's a bad day.
It's a bad day, yeah. So, and there was a picture in one of the magazines, or not a picture, even a video of this happening. So that's what we have to do, is explain that titanium can solve all these problems and give it a long, long life so they don't have to worry about maintenance and that kind of stuff. Tim, you have something else to say?
Yeah, one, the video, you have to see this, and I know Rob Henson has it. It's just beyond belief. Secondly, the way that I see titanium can gain acceptance in the marine market is for OEMs, people who build skids. For example, one of our product lines is refrigeration and air conditioning, and these are always skidded, built in a factory, dropped into the ship. So they're not part of the shipyard welding. And by getting OEMs to use it in their products, whether it's refrigeration, ballast water treatment, whatever it might be, and then bolt into the steel piping that represents the balance of the vessel, that's where people will begin to appreciate the life and the maintenance-free aspects, which is essentially what we see with the small heat exchangers. So
I'm sorry,
bit
go
by
ahead.
bit, yeah. Go ahead.
I was going to say, the other thing is that titanium has going for it is the weight. Its density is half that of most of the nickel alloys. And all of this is especially retrofit, is above the waterline. So it either requires more ballast in the ship, or you can't carry as much cargo. So that titanium would save almost half the weight if you made a scrubber out of it instead of nickel alloy.
Well, one thing I'd like to leave the audience with is something that Rob Henson and I stumbled across as we were learning more about scrubbers, and we got hooked into a gentleman who was the scrubber SME with a particular cruise line. And he advised us of a problem that's emerged in the last 3 or 4 years. It's real simple. When you have a scrubber, you have massive amounts of seawater going through it, typically 16 to 18-inch diameter lines. That's a lot of water. And as you discharge it below the water line over the side, well, guess what? It's acidic. It's got sulfur in it. And hard as it may be to believe, that acid plume that is created around the exit from the ship starts to attack the ship right at that exit point. And doesn't seem like it would be a big deal, but it's an incredibly important and critical issue, because that's a water boundary with the balance of the ship. So we're working with this same fellow to see if we can come up with a solution, and clad plate may be part of that solution, to put in, as you would with a dielectric insulator, some sort of protective radius around that 18-inch discharge pipe, so that the ship doesn't basically rot out from underneath you. Nobody saw this one coming, and titanium clad is a very promising solution to that. They are looking at fiberglass and plastics and coatings, but we've all been there. You know, you can do it once, or you can do it over and over. But that's an emerging opportunity for those of us that are, you know, in that sector.
This is Rob Henson. Thanks, Tim and Chuck, for that. The video you mentioned was posted by the Japanese ship classification company, Class NK. I do have a link to that video. I'll get it to Jennifer. We'll include it with the recording of this. I can't get my hands on it at this moment without leaving the chat here. The other comment I was going to make, Class NK, DNV, and ABS have all issued advisories to ship owners about these overboard piping components. They typically wear carbon steel, which is a water boundary on the ship, coated with epoxy. And that is not a robust solution or a long-term solution to this problem. So there is clearly an opportunity there, and the fact that these ship classification companies are issuing advisories tells us that the problem is very real. So that's what I had to say. Back to you, Wendy.
Thank you. David Sear has posted the link to the video in the chat box. So if you check there now, you can copy that and paste it to your browser later.
You got to see it. It looks like something out of the Poseidon Adventure. It's just unbelievable.
All right. Well, thank you, everyone. We have, I guess Jennifer has the last poll up. So this is all the different technical conferences that this group participates in. Looks like we have a lot of people involved in NACE and MTI as well, and some in ACMA. So great. Well, we're just a little bit over our time limit. I don't see any raised hands. So if there's no further questions, then thank you all for joining. And hopefully the next time we meet, we'll actually get to be in the same room. I'm sorry, Rob, did you have something you wanted to say?
Yeah, if I could, just to extend a minute here. I want to put Chris Wilson back on the hot seat and circle back to the discussion about enhanced grades for explosion bonding. There were some comments about ruthenium alloys. And Chris, in your presentation, you indicated that the ruthenium grades were just not available. And I wonder if you could expand on that and give us an idea why the industry is not pursuing these ruthenium grades, given the price savings over palladium.
Well, I think the big issue, and Bill alluded to it, is the higher melting temperature of ruthenium. Most titanium melters do not want to have any of the scrap or ruthenium in their shop. That's really what it comes down to. RTI had a patent on a method to alloy the ruthenium and use that as an addition, which lowered the melting temperature. But as of right now, well, maybe they may be getting back into it, but I don't know of anyone other than RTI that was capable or willing to melt the ruthenium grades. There is definitely some merit to the properties, the increased strength, the lower cost, but I wasn't able to get a lot of data or a lot of information because there's just none out there right now. It's not to say that, as I think Steve mentioned, some melter may be willing to do it for you, but it comes down to control of that scrap, control of that material, making sure it doesn't get mixed in the melt shop. The higher melting temperatures become a real issue when it gets into the scrap stream. So that's why we really haven't done anything with it, and I know TimeMed has never done anything with it. So most melters just shy away from it. They don't want to touch it. I think that's the general industry thoughts on it. I'd throw it out there for anyone else to comment, but that's my 2 cents worth.
Thanks for that. So,
Did I answer your question,
thank you,
Rob?
Wendy.
Okay.
That's it.
All right. Well, then I'll just do one last check here. Looks like there's no further questions. So again, hopefully, like I said, the next time we meet, hopefully we'll get to be in the same room and across the table from each other. Thank you everyone again for joining, and see you again.